Welcome to Kenton's videos. Enjoy the video.
You begin by ensuring your data is clean and shaped correctly. This is crucial. Once that's ready, implement fast vectorized operations with NumPy so training will be efficient. Next, create a layer abstraction. Initialize weights with small random values, store biases, and code forward and backward methods. Make sure to include shapes and broadcasting checks so gradients match. Once done, wire a simple sequential container to chain layers and prepare for the first training loop. Now you build the training loop. Batch your data, run forward passes, compute a stable loss, and then run backpropagation to collect gradients. Implement parameter updates explicitly. Start with SGD and add momentum to smooth updates, then atom for adaptive steps. Also integrate a learning rate schedule and gradient clipping to prevent explosions. Monitor training and validation metrics each epoch so you can detect overfitting early. Once gradients update weights correctly, validate with a small held-out set to confirm learning. To finish, implement robust evaluation, compute accuracy and class-wise metrics, and inspect the confusion matrix to find systematic errors. Then serialize weights plus normalization constants and hyperparameters so you can reproduce results. If performance is poor, first check gradients for vanishing/exploding signals. Next, experiment with learning rate, batch size, and weight initializations. Make sure there's no data leakage between train and validation sets. Finally, run a few diagnostic runs with
Thanks for watching. Consider subscribing if we helped you.